everyone, welcome back to the Internet Report, where we uncover what's working and what's breaking on the internet, and why. This week we're discussing outages at Google and GitHub. We'll also share insights about what happened during the recent X Livestream event featuring Elon Musk and Donald Trump. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Cisco Thousand Eyes. As always, we've included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to give us a follow over at Spotify, Apple Podcasts, or wherever you like to listen. So let's get the show underway, and I started by asking Mike to explain what happened with a Google outage which occurred in mid-August.
On August the 12th, there was this Google Cloud outage, as you said. Now, it affected the availability of the Google Cloud CDN, some load balancing, some hybrid connectivity, and the virtual private clouds, the VPC, and sort of services associated with those. So these were things like sort of Gmail, Google Calendar, Google Chat, Google Docs, and a few things like that. Now, what actually happened was that and we know this from Google, they said in the status report, there was a power failure. So one of their subsystems actually failed, and also the secondary system failed as well. It failed in Google's Europe West 2 region, which is actually in London. And what it actually did was specifically take out that one area. Now, although there was sort of impact across the globe, what we actually saw was it impacting the front ends, the Google front ends. So coming into those locations. So the services themselves were up and available, but if you had a workload running in that region, you actually couldn't get to it.
This incident appears to have been confined to the UK. What might have caused that? And why would Google not reroute to, say, other European sites if there was a localised issue in the UK?
Yeah, it's a good point, but they actually did reroute. So if we actually look at how the outage manifested, and we saw that time, it was actually out, it was down. As I said, it impacted that sort of Google front end. So it took out that first layer. So then what happens is then those routes get withdrawn. So the network equipment's down. We can't actually send anything out. So those are withdrawn. So people coming into that region itself couldn't actually reach that region. As I said, if you had a workload running in that region and associated services, you couldn't actually get to that system there. What then happens is once those routes are withdrawn, then we have to wait because of propagation and time like that, you have to wait for sort of things to come back up. So if you then start to look, and we saw this through our data, if you actually start to see, we'll sort of see stuff coming from a local ISP or from an ISP, going to Amsterdam and then coming back into London, or going to Amsterdam and coming that way. So it's actually coming externally into sort of the Google network as it was. So we did see that. Now, what then happened was, like I said, so you saw this period where things were unavailable, you couldn't actually get to it, and then they started to come back up and we saw latency. So you saw this increased latency because we were taking a different path as we sort of got there.
And even such a short hop from London to Amsterdam, which is a few hundred miles, is going to create extra latency, right?
Yeah, exactly. So every time you come through each one of these hops, I have to effectively come up the OSI stack. So I have to come in, I have to process that information. It goes into an ingress buffer. Where's my next path? And that's hop there. So it really is, the more hops I have in there, increase that latency. And this is then why we talk about this concept. If we're going around the world, it might be easier to go one hop as opposed to sort of 20 hops, even though that appears a local one, because you're sort of going up and down into those paths.
What lessons do incidents such as this one leave for NetOps teams?
A couple of things really we'll sort of consider here. Now, we've always talked about this distributed resources. So in this case, we had distributed resources around there. Like I said, it was one availability zone. We noticed it impacted the local people. But also then if I had a part of the Google network which was coming in, I was trying to go into region with those, and my terminating point happened to be at that London point, then we're actually impacted itself. So it's really understanding specifically where my resources are, why I'm accessing them. You know, if we sort of think back to when we had those submarine cable cuts, what we actually found there was then all of a sudden there was components within a particular region that were impacted. We didn't think it was there, but it had a dependency in that. So identifying everything in my digital service chain, I can actually say, right, I've got that serving out from there. Also, then what you have to do is you can say, well, when we have these situations, I'm actually going to take steps to mitigate this by spinning up another load, changing a different service out from there. But also, again, I can also then start to remove those dependencies around there. So I say, right, what we actually need to do is we actually move that. So I'm going to duplicate that function. Now, this might not always be possible to do that, which is why you then have this idea to identify where it is. I know who's going to be impacted. I know which region it is. I can take steps for those people individually.
GitHub was down for around half an hour on August the 14th. Explain what happened here, Mike.
So between 11:02 p.m. UTC and 11:38 p.m. UTC, this is where GitHub experiences complete service outage. When we say service outage, you could actually get to the GitHub site. So you could get to the system. You've had a plugin that wasn't working. GitHub have actually come out and they said this as the outage was going on, to identify it during this process, it was caused by an incorrect configuration to the database itself. So it was the traffic routing within the database infrastructure. And then they said this resulted in critical services losing connectivity. So as I said, you could get to the system, but then you couldn't do anything. Now, why this becomes interesting is that we're also talking about the plugins. And why it says interesting is because that tells us we're looking at an application issue. So we could get to the network itself. Now, if we actually looked at what was happening, we were looking at through the Thousand Eyes test, what we could actually see was this 503 service unavailable. So when I went to load the page, I saw 503 service unavailable, and this was coming back. Now, this tells me, again, service unavailable, but it also tells me that I'm getting a response from the server. So, if I was just simply timing out, then I might have some sort of connectivity. But the fact this wasn't there meant I'm actually making a request and it's coming back and saying, hey, there's a problem here. It's just not available. We can't service that one there. Then tying that into another signal, what we actually then start to see was the page load time. So if I'm looking at this from a web perspective, a website perspective, we have the page load time. Now, this started to get faster. So we saw a better page load time occurring during this thing now. Now, again, we've talked about this in the past. Normally, we would say, okay, it's got faster. That's a good thing. But then what we saw this then taking that signal in conjunction with the 503s and then looking at the components were loaded, we know, we're failing to load some components in there, or we're failing to load some part of the system itself. We're unable to retrieve the data, I said. So again, starts to give us clues of what's going on. The other thing I'll say about this is that we looked in the application, we could get to the front door, we could see these 503s, and was failing across all systems. So we know it's across the application itself. The fact then this is distributed, and this was a global outage at the same time. So this was service unavailability to everybody. Then we actually know, okay, this lies within the application. As I said, little clue, they did tell us, hey, we got a problem here. We made a configuration change and we rolled it back. What that reveals to us, like I said, is that this configuration change might have actually sort of identified some form of single point of dependency. So the fact we took out everybody at the same time. I had no performance or no availability during that time.
GitHub's incident report said that the configuration error impacted the ability of the database to respond to health check pings from the routing service. Explain what's going on there and the purpose of the health check pings.
The ping is what it says on the label. It's actually doing this health check, and we have to do a status check all the time. Are you up? Are you up? And start to get that information coming back. Ping is actually not a verb, but it was originally done sort of packet internet groper, but it's been sort of changed over time to reflect that sonar. That's what it was. We send out the information, we get a ping back. So it's doing that, and it's saying, are you healthy? Are you available? Can I reach you? So it can get there. Now, you do that to maintain the routes and the paths between there. So we actually want to make sure that we've always got connectivity. We don't want something to effectively go to sleep. We're dealing with this in the back-end system. We're also talking about distributed. When we're talking into these repositories and the data we have within this, we have this highly distributed database around there. So I constantly need to be able to have them updated, so I can't have locks and have all this system communicating with each other. Now, if that goes away, then what I'm actually going to do is I'm going to start impose locks on it. Because I said, what you can't have is this break in a database. I can't have one part of the database updated and not reflected in another part and another distributed environment there. So if I don't respond, then it's almost like a safety mechanism where you sort of fall back on that perspective.
GitHub said it was working on faster rollback functionality as part of its remediation from this incident. Explain some of the challenges of rolling back an update.
Depends on what the update is. But first of all, I've got to know it has failed. So I've got to know the update I've actually made is having an adverse effect on the system itself. So I've got to see that it's actually not performing as I'd expect it to be, or worse around there. So the first thing is I need to identify what's going on. And then depending on how complex that change is, and sort of, or complex is maybe the wrong word, but how fundamental it is. So how deep does it go into the system? If I had to change part of the code, I've had to do all these things. How can I sort of roll it back to there? In some cases, it's just simple. We had a configuration change. If again, go back to my old days when I was dealing with the stat muxes, we had sort of these configurations and you had a hot and a standby configuration. If we made a change, you could just simply click the buttons on the screen and roll it back over to another one. It really was a touchpad on the front of the multiplexer. So you could actually roll it across there. So that was very simple because I had it already stored in memory. But if I'm making fundamental change to the code that impacts something else, then I have to unwind several stages. And sometimes it's just not possible. So I said, first of all, identify where that problem is. Yep, we've made this configuration change. How deep does this go? Let's roll that back. Or there's no way we can roll that back. We're going to have to do some sort of mitigation. We're actually going to fix the fault that occurred there. We live in this world where we're doing agile development, and therefore we have all these smaller modules, as it were, when we're sort of developing code. So it may well be sort of understanding the relationship between those, breaking it down to smaller modules, removing some of the dependencies so that we can make a change, or even bringing this into testing. I don't know what it's going to be, but all these types of things you can start to implement around there, breaking up the problem into smaller problems, and therefore then easier to sort of back out from those. The other thing I'll say about this, once we've had a configuration change or some sort of update that we're rolling back, then what we have experienced in the past is a few days after, then that will have to be attempted again, because this change has been made for a reason. So, we've made it to improve stuff or to patch something. That still has to be implemented. Otherwise, we wouldn't put it in the first place. It's always interesting to watch in the few days after to see whether something occurs again, another issue, which may indicate they've either sort of identified the fault and fixed it, or it's led to something else.
On August the 12th, a live stream discussion between Elon Musk and former President Donald Trump, hosted on X's audio streaming platform Spaces, kicked off 40 minutes late, with error messages displayed to many users who tried to tune in on time. The delay was attributed to a DDoS attack. What symptoms did you notice, Mike? And did you see any indicators of a DDoS attack?
So when we think about a DDoS attack, what it actually is a denial of service. The DD is a distributed denial of service. So it's coming from a large area. And what it is typically a large amount of traffic that's sort of said to overwhelm it, with the objective to render the site or the application inaccessible. Now, while we can't definitively state the underlying cause of this disruption was actually a DDoS attack, during the 40 minutes at the start or during the entire broadcast, Thousand Eyes did not observe any traffic conditions that we'd typically expect to be present during a DDoS attack. These are things like network congestion, packet loss, and elevated latency. As I said, things that are going to sort of deny the service. Now, if you want to sort of take that back to sort of where we see known patterns before, we have some sort of outages that occurred where we can go back and the organization themselves has definitively said this was a DDoS attack going on. We had one recently where it was a very small DDoS attack going on, and then the weather mitigation service kicked in. It actually sort of incorrectly rerouted, used some configuration as it rerouted the traffic. So the site itself wasn't compromised, but how the traffic was being sent around was. But again, how this manifested itself was very much in seeing this huge loss rate. Because if you think about what loss is doing, when I'm seeing loss, my packets are lost. Therefore, I'm not actually getting to that site, to that application, and therefore I'm denying service to other users getting to there.
How do the symptoms of a DDoS attack differ from an influx of legitimate traffic?
So if you think about when you have some sort of major event happening, I can expect an influx of legitimate traffic. Now, we say DDoS attacks leave quite distinctive signals. So the obvious one is that this service is unavailable. I actually can't get to it. So that's, it's achieved its aim. But also associated with that is this high level of loss rate. And then tied to that as well, what I'm also potentially going to see is I'm going to target an entire service, not an individual user, not an individual account, not an individual application or a subdomain within that environment. I'm looking to specifically take out the overall site there. Now, there is attacks which can specifically target at an application level. But again, there's no sort of signals of that. What you're seeing from those is you actually see something that would result in an excessive amount of requests. And again, each of those I'll actually see some sort of disruption and break in the service itself. So like we saw the 503s from the GitHub, I'd expect to see something like that coming back because I'm looking to go to a subdomain.
Finally, Mike, let's turn to the overall outage trends and what we've seen over the past couple of weeks.
For the global outages to start, we saw an increase of 11%. That was in that first week, and then 3% the second week of August the 5th to the 18th. Now, that was in contrast to the United States, where we initially saw outages increase by 32% in the first week, but then they decreased by 23% that second week. Now, despite this decrease in US outages, they still accounted for at least 40% of all global outages during this period.
Global outages appeared to rise in the second week, but US-centric outages dropped. Any indication of why that might be?
So I think it has a lot to do with what we saw in relation to the outage during this period. Now, if you take the Google Power outage specifically, they occurred outside the US. We said they occurred within that European region, but they also impacted the partner connects. And this sort of triggered a number of network failures in other providers. So we had these sort of downstream providers there. So the actual number of outages that you saw occurring on nodes would have increased from there. And then if we look at the network outage in the US, they actually appear to be sort of in line with what we typically see this time of year. And if I look at those and go into detail, then they're engineering type of work and short duration, sort of localized blips. So some of these were occurring out of hours, and then the ones which occurred during the business days it was from a US-centric perspective, they were quite short in duration and they looked to be automatically remediated as also quite localized, so that outages sort of didn't spread. So where we had the other ones, where we had these downstream providers or connected providers within the partner interconnect who were affected, when I saw an outage in the US, they were sort of fairly localized. So one didn't lead to two, it lead to three.
That's it for this show. Please like and subscribe. We really appreciate it. And not only does this ensure you're in the know when a new episode's published, it also helps us to shape the show for you. You can follow us on X at @thousandeyes or send questions and feedback to internetreport@thousandeyes.com. Until next time, goodbye.